Generic types, traits, and lifetimes. Every programming language has tools for effectively handling the duplication of concepts. In Rust, one such tool is generics. Generics are abstract stand-ins for concrete types or other properties. When we're writing code, we can express the behavior of generics or how they relate to other generics without knowing what will be in their place when compiling and running the code. Similar to the way a function takes parameters with unknown values to run the same code on multiple concrete values, functions can take parameters of some generic type instead of a concrete type, like i32 or string. In fact, we have already used generics, in Chapter 6 with option t, Chapter 8 with vect, and hashmap kv, and Chapter 9 with result te. In this chapter, you will explore how to define your own types, functions, and methods with generics. First, we'll review how to extract a function to reduce code duplication. Next, we will use the same technique to make a generic function from two functions that differ only in the types of their parameters. We'll also explain how to use generic types in struct and enum definitions. Then you will learn how to use traits to define behavior in a generic way. You can combine traits with generic types to constrain a generic type to only those types that have a particular behavior, as opposed to just any type. Finally, we will discuss lifetimes, a variety of generics that give the compiler information about how references relate to each other. Lifetimes allow us to borrow values in many situations while still enabling the compiler to check that the references are valid. Removing duplication by extracting a function. Before diving into generic syntax, let's first look at how to remove duplication that doesn't involve generic types by extracting a function. Then we'll apply this technique to extract a generic function. In the same way that you recognize duplicated code to extract into a function, you'll start to recognize duplicated code that can use generics. Consider a short program that finds the largest number in a list as shown in listing 10.1. Let number list equal vecbang 34, 50, 25, 165. Let mute largest equal number list index 0. For number in number list, if number is greater than largest, set largest equal to number. Print line, the largest number is largest. This code stores a list of integers in the variable number list and places the first number in the list in a variable named largest. Then it iterates through all the numbers in the list, and if the current number is greater than the number stored in largest, it replaces the number in that variable. But if the current number is less than or equal to the largest number seen so far, the variable doesn't change, and the code moves on to the next number in the list. After considering all the numbers in the list, largest should hold the largest number, which in this case is 100. To find the largest number in two different lists of numbers, we can duplicate the code in listing 10.1 and use the same logic at two different places in the program, as shown in listing 10.2. Yep. Although this code works, duplicating code is tedious and error-prone. we also have to update the code in multiple places when we want to change it. To eliminate this duplication, we can create an abstraction by defining a function that operates on any list of integers given to it in a parameter. This solution makes our code clearer and lets us express the concept of finding the largest number in a list abstractly. In 10.3, we extracted the code that finds the largest number into a function named largest. Unlike the code in listing 10.1, which can find the largest number in only one particular list, this program can find the largest number in two different lists. Function largest parameter called list type reference to a vector of i32s? Could that be an array of i32s? I don't know. And it returns an i32. Let mute largest equal list index 0 for reference to item in list.iter. If item is greater than largest, then largest shall equal item. Down at the bottom, the return value is largest. And then in the main function, we have let number list equal vecbang, and then a vector of numbers. Let result equal largest, taking as an argument a reference to the number list vector. And then we do it again. They shadow number list with different numbers, and then just run it again. The largest function has a parameter called list, which represents any concrete slice of i32 values that we might pass into the function. As a result, so slice is, I guess this is, so it's a reference to a vector slice. Oh, it's a slice type. Okay, so being a reference makes it a slice type. It is a slice of a vector of i32s, but I don't know why that's not the notation for an array. Okay. As a result, when we call the function, the code runs on the specific values that we pass in. In sum, here are the steps we took to change the code from listing 10.2 to listing 10.3. Identify a duplicate code, extract the duplicate code into the body of a function, and specify the inputs and return values of that code in the function signature. Update the two instances of duplicated code to call the function instead. Next, we'll use these same steps with generics to reduce code duplication in different ways. In the same way that the function body can operate on an abstract list instead of specific values, generics allow code to operate on abstract types. For example, say we had two functions, one that finds the largest item in a slice of i32 values, and one that finds the largest item in a slice of char values. How would we eliminate that duplication? Let's find out.